We'll now develop our VR pawn and add logic for handling different VR head-mounted displays, or HMDs, as well as their motion controllers. I want to start by quickly demonstrating a benefit and the reason we're using child classes with our player pawns. We're going to be taking advantage of inheritance. We'll create functions in our parent pawn as well as in our VR pawn to prepare the game and prepare specifically for VR. We'll learn how to detect which HMD is being used by the player and set up game logic to accommodate. After that, we're going to create a new blueprint class for our VR hands and write a function to spawn and attach them to our VR pawn. Let's get started. Inside of the player folder, open the BPP pawn as well as the BPC VR pawn. Click to open the full blueprint editor. You can always find the parent class of your blueprints in the top right corner. Inside of our BPP pawn, the parent class is pawn, but in BPC VR pawn, the class is BPP pawn. So BPC VR pawn is a child of BPP pawn, which is a child of pawn class, which is a child of actor class, which is then a child of object class. So BPC VR pawn will inherit everything that all its parents contain, from the ability to exist in Unreal Engine to being placed in a map and contain a transform to be able to be possessed by a player is all inherited. Let's see an example of this in action. Create a new variable in BPP pawn. I'm just going to quickly name it test variable and compile. We can now go to our BPC VR pawn, turn on show inherited variables, and you will see that we have access to read and write test variable if we wanted. We can also create a new function in BPP pawn and name it test function. You can compile this. And inside of BPC VR pawn, we can click override and find our test function. It will then insert it into the event graph. Just one last thing to demonstrate on inheritance for our future update. If we open BPC PC pawn and open full blueprint editor, you can see that it also contains the same variables and functions. So it makes it very easy to build a single parent that contains one or many variables and functions that will be shared between two or many assets. Okay, let's delete the test function and variable and compile again. Let's start developing the VR pawn. Create a new event inside of BPC VR pawn called Prepare VR Environment. There are a few functions we will need to set up the VR environment for whichever HMD the end user will be using. So when I say to prepare for any HMD the end user will be using, I mean we will prepare for any HMD that is plugged in, set up, and readable by Unreal Engine. We will build the means to discover which HMD is being used, but I will be designing for the Oculus Rift, as that is what I'm using. Don't worry if you have another device. We will go through how to develop for other devices as well, and you can expand on it to make it compatible for any or all devices if you choose. Let's make a new function and name it Identify HMD and place it in the HMD category. First thing we need is the name of the HMD device that Unreal Engine finds, and we'll switch our logic based on what it returns. If you are developing for an HMD that is different than the one I have, and you don't know what the device name that is returned, you can plug this name into a print screen function to find out. Or, of course, search online for an HMD that you are developing for but don't have access to. So, I'll add 3 options together with the default, giving us 4 varieties we can develop for. The first one will be the one that I'm using, which will return the name Oculus HMD. Then Vive and PSVR. If you had another one you wanted to develop for, just click plus again and provide that device name. For ours, if it is not one of these 3, it will choose default. In order to save the value it finds, let's make a new enumeration asset. Go back to the enum folder and create a new enumeration. Name it eHMD type. Open it and put in recognizable options that are similar to the ones we put into the function. Go back to BPC VR pawn and create a new variable named eHMD type and place it into the category called HMD and compile. So if it's Oculus that is returned, it will set the value to Oculus, and so on. Let's comment that this sets the value of eHMD type, and I'll color it black. Drag Identify HMD into the event graph and hook it up to Prepare VR environment. Next, we want to set floor for HMD. We'll use a function called setTrackingOrigin to do so. Drag off the origin input and type select. Now plug our eHMD type into the index of the select node. Now we can set different values all based on the value that the function identifyHMD set to our variable eHMD type. Oculus and Vive both use the floor height to set the camera height, and PSVR uses the eye height. Let's comment that this will move the player camera based on the HMD. This function tells Unreal Engine that the HMD wants to use the floor as the base of where to begin setting up the height. Usually that's set up when you set up your sensors. So if you're 5 feet 10 inches or 178 centimeters tall and set your sensors up, it will make the camera that height relative to the player pawn's camera position. If your camera is on the ground, you will see it as if you were 5 feet 10 inches tall. If your camera is set at 5 feet 10 inches, you would be 11 feet 8 inches tall. Eye height, on the other hand, places your HMD directly at the location of the camera. Place this function in the HMD category and drag it into the event graph. Next, we want to make a function named EnableHMD. This one may seem tedious, but because we are starting first on PC and then switching to VR mode, we need to make sure that that change happens and Unreal connects to your HMD. If you have the game auto starting in VR, you do not need this function. So let's comment that as a message. And this one I will color a yellowy color so I know it's a note. You may also not notice a difference with this function because the effect of it does not happen inside of Unreal Engine. It will only become apparent post-packaging. Drag off Enable HMD and type the same. Set Enable to True and compile. Drag this function into the event graph. Now let's spawn the VR hands. Create a new function called Spawn VR Hands. Place it into the category Motion Controller. Let's put that inside of HMD. So HMD vertical bar motion controller. Here we will do the same sort of things 2 times. So let's use a sequence. We don't have the VR hands created yet, so I'm going to leave a note for myself for what I intend to do here. First, I want to spawn the new BP class and then attach them to a component. Let's create that new BP class for our hands. Go to our player folder and create a new folder named Motion Controller. And inside, create a new blueprint class of type actor and name it BP underscore VR hand. Add a motion controller component. Later, we will migrate in some hands, but for now, let's just use the visualization that the motion controller component provides. Scroll down in the Details panel and turn on Display Device Model. If it detects an HMD, it will automatically give you that one as an option, assuming it's a model that Unreal Engine contains. My HMD is the Oculus, so it will detect that Oculus HMD is running and provides me the Oculus HMD as an option. Let's create a new variable of type eControllerHand. It's provided inside of Unreal Engine, so we don't have to make it. We need to make it instance editable and expose it on spawn so we can change the value from our pawn. Before we go, open the construction script and drag our variable into it. Drag off the enum and convert it to a string. Bring over the motion controller component, and let's set the motion source to the value of our enum. And compile. Go back to the VR pawn, and let's finish this function. First, add the components we will attach the hand to. Add a scene component and name it VR root. Next, add a camera and compile. Add a spawn actor from class node. Set the class to our BP VR hand. Expand the node to see all options. Drag off the spawn transform and make a transform. Also drag off owner and type self to get a reference to this pawn. Promote this newly spawned actor to a variable and name it left hand. Drag off left hand and attach to component. Drag VR root to the parent. Set the location and rotation rule to snap to target. And now we'll do the same thing for the right hand. Be sure to set the value of E controller hand to right. Place these two variables in HMD vertical bar motion controller. And compile. Back in the event graph, we're going to want to make sure prepare VR environment gets called at the start. Let's comment that. Okay, I want to point out something you should not forget when using parent and child classes. If you have something on your parent's begin play function, make sure you call it from your child's begin play. Otherwise, it will not be called. So right-click Event Begin Play and select Add Call to Parent Function. Before we forget, let's make sure we add the Spawn VR Hands function into the event graph. I would like to test all of this and make sure it's set up correctly so far. We need to go to our game mode and change the default pawn being spawned to our VR pawn. Remember that I'm using an HMD that is set to floor level. That means we need to go to our map and drag down the player start so that the actor's transform is directly on the floor, which will place my HMD to my height. Let's press play in VR. There we go. We're in VR, and my camera appears to be in the correct spot, and I have VR hands. That's great. We now have a VR pawn that is spawned and initialized for use with the available HMD and motion controllers. Now let's create an adaptable function where we will set up the inputs that our end users will use to interact with the scene.